Hello, this is Math 2134 coming to you from the College of DuPage during the fall of 2020, and this is the conclusion of the lecture entitled Pre-Calculus Review 1. I'm reminding you here of some useful product formulas. A plus b whole squared is a squared plus b squared, but then there's a middle term. It is 2ab. Make sure you understand these examples. Here, a minus b whole squared is going to be a squared plus b squared, but then minus twice the product of the middle term. Here, when you FOIL this, the middle term will cancel out. So a plus b times a minus b is a squared minus b squared. So we'll use these to factor also when we're simplifying expressions. Here, the first thing you do in a factoring problem, the last thing you do in a factoring problem is think about factoring out the greatest common factor. Here we have 4 different problems. I'm going to encourage you to factor out the greatest common factor in each expression. You know what to do. Let's see how you did. So for A, you should have gotten minus 3t, t minus 1. For B, the greatest common factor is going to be x to the 1/2, and you get x to the 1/2 times the quantity 2x minus 3. And here the greatest common factor is going to be 2y e to the xy squared times, and then it is 1 plus xy squared. In the last one, you're going to factor out the greatest common factor is going to be x and x plus 1 to the minus 1/2. And so when we do that, we get this as my final answer. And you should observe that whenever you take x plus 1 to the minus 1/2 times, and this is x plus 1, and the net of this is all to the 1, then that's going to be x plus 1 whole to the 1/2. Here we have 4 terms. That means we're going to be doing group factoring. Please give this a go. You know what to do. Let's see how you did. So here we factor 2a out of the first term and b out of the second term, getting this. But now we observe that we have a common factor of x plus y left. So we factor that out, and now we have the final answer is 2a plus b whole times the whole of x plus y. Here we have to rearrange terms, but we can rearrange terms, so we're going to factor the square root of y out of these two. We're going to factor 2 out of these two. Both times we're left with this as a remaining factor. So when we factor that common factor out, we can have 3x minus 2 times the whole of the square root of y plus 2. And again, these first 3 formulas are in fact just reading the formulas we had from the reverse. You use these to factor. Here's an additional 2 formulas dealing with the sum of 2 perfect cubes and the difference of 2 perfect cubes. Make sure you're familiar with these examples. And here we're to factor these 3 problems. You know what to do. Let's see how you did. So here you can factor this into 3x minus 2 times x plus 2. Here you factor out the common factor first. So at the end we'll have 3 times x minus 4 times x plus 2. And on the last one you're going to have minus 3. This is going to be t minus 65 times t plus 1. Now the roots of the polynomial are precisely the values of x that satisfy it says the given equation, but that means f of x is equal to 0. So the roots are found when you set it equal to 0. One way to find the roots of a polynomial is to factor the polynomial and then solve the resulting equation. For example, here, first thing you do is factor out the common factor, and then you continue factoring. So this will factor into x times x minus 1 times x minus 2. But this can be true only when one of these is equal to 0. So either x is equal to 0, x minus 1 is equal to 0, or x minus 2 is equal to 0. So the desired roots are x equals 0, 1, and 2. Now, in general, the problem of finding the roots of a polynomial equation is a difficult one, but the roots of a quadratic equation, a polynomial equation of degree 2, are easily found either by factoring, or if you cannot factor it easily, you can always use the quadratic formula, which says the solutions of the equation ax squared plus bx plus c equal to 0 if a is not 0, and notice it is being solved so it is equal to 0, are given by x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And again, you must make sure that you're in the standard form ax squared plus bx plus c equal to 0 before you begin solving it that way. So here's an example for you to do. You want to solve these quadratic equations. Let's see how you do. Let's see how you did. So the first one is in the standard form. So a is 2, b is 5, and c is minus 12. So we use the formula, simplify things carefully, and we get as minus 5 plus or minus 11 over 4. We should complete the calculation. We find that x is equal to minus 4, or x is equal to 3 over 2. You also could have factored it and said each factor equal to 0. You would get the same answer. For the second one, you have to reorganize this into this form. X squared plus 3x minus 8 is equal to 0 before you know what a, b, and c are. But now we know a is 1, b is 3, and c is minus 8. So use the quadratic formula. You substitute in. You get minus 3 plus or minus the square root of 41 all over 2. Now you don't know what the square root of 41 is, so this is an exact answer. You could leave it that way. If we were doing approximations, and if you could use a calculator, you would find out that this first root is around 1.7 and this next root is around minus 4.7. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself and of each other. God bless you all.